Wonderful. So whatever I just said, I'll just repeat. Okay, so this is our new topology. Okay, Palo Alto 1 and Palo Alto 2 both are connected with directly connected with interface Ethernet 1x5 and 1x6. Okay, and two interfaces, one from PA1 and one from PA2, connected to router in case if we do some research or test something if we want. Okay, rest all the connectivity is just same. Okay, so now I just turn on these four appliances, two PA, one switch, and one workstation. Okay, so we are in workstation now, and now I'm able to reach my Palo Alto 1. I'm logging in into Palo Alto 1. Okay, so in our last lecture we did failover, but failover was not happening. It was showing me it was showing me failover down. So today we'll do that practical and proceed with our next lecture. Okay, so very first thing that we do in failover is we go to network. Okay, and we create two interfaces for HA, that is high availability. Okay, so I'll just take interface 1x5 today, as it is directly connected to other PA. Okay, give it OK. Now it is in HA mode, 1x6, HA mode. Okay, I'll not include 1x2. Okay, I cannot do now. Okay, let's leave it for the time being. Now what I just did is configured Ethernet 1x5 and 1x6. As you can see from topology, 1x5 and 1x6 interface. They are connected directly to both the Palo Altos. Okay, so I put both the interfaces in HA. After doing this, I'll go to my device tab. In device tab, I'll go to setup. In setup, I'll click on edit, enable HA. HA type is active passive. Peer IP 192.168, as we are on 10.10.10.1. So we'll keep our neighbor 10.10.10.2 as we did. Yes, it is 10.10.10.2 here. So likewise, we'll keep the symmetry of IP addresses. We'll keep .2 on other end. Okay. So I have just did enable config sync. I click OK. Wonderful. Now after that, I will define what will be the passive link state. Okay, I have defined like shutdown. Okay, so monitor hold time is 1 minute. After 1 minute, it will do failover. Okay, then I go to election settings. Okay, which firewall will be active and which firewall will be in standby state. So priority, more the priority, more the priority and device will be in standby. Lesser the priority, the devices will be in active state. Now then preempt is nothing, just to check whether my high availability or my failover device is available or not. Okay, after that HA timers. I have set aggressive, like if my any of my monitor link or service goes down, my other PA will take care of it aggressively. It will not wait for much time. Okay, then after that, the main part of this course, that is controlling HA1. Okay, now here I'll define control link. A theory we already have covered in our last lecture. Okay, so control link, I'll go to Ethernet 1x5. Okay, IP address, local IP address 1.1, subnet mask of that, and this is my gateway, right? So let me keep subnet mask more constraint. Let me keep it 248. Okay. Likewise, I'll do here HA2. I'll define interface Ethernet 1x6, and again I'll keep subnet mask 248. Okay. Okay. So subnet mask. Okay. Now link and path monitoring. I'll monitor two interfaces. I'll give name mon1. I'll monitor two interfaces, Ethernet 5 and Ethernet 6, because they are HA interfaces. Okay. Okay, now we are all good. Now I'll go to commit and see whether I'll be able to commit or not. Let us see. It is saying fail. Okay, it is saying HA1 backup and overlap. It is saying me that HA1 and HA1 backup both are same, and which should not be same. Okay, so I'll keep it management interface in that case. Okay, now it will take it. Now it will take the configuration. Let's do the same on other side. Go to network, go to interfaces, 1x5, make it HA interface. See guys, if I'll not make this interface as HA, like say Ethernet 1x6, it is in tap mode. Okay, if I'll go to device, and if I go to HA2 and choose 1x6, I'll not get option of 1x6 till the time I configure that interface in HA mode, right? So just for an understanding. So 1x5, 1x6, HA, okay. Now go to devices. Now device high availability, settings, okay. Peer .1.1, wonderful. After that, election settings, priority, high priority, low preference, low priority value, high preference. Preempt, aggressive. Now configure HA1, 1x5, okay. 1x6, okay. So before proceeding further, I just want to show you that in our dashboard, This is the status. H high availability, HA. Active passive, local is active, peer is unknown. HA1 is down, HA1 backup is down, HA2 is also down. Rest all is yellow. Okay, so just to show you, here it is not configured, so HA not enabled. But as soon as we go to devices and then click on link and path monitoring, 5 and 6, wonderful. Now go to commit. Now it will commit. Okay, commit pending, successful. Okay, okay. So here I'll see dashboard up, 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 up. Everything is just up. HA initializing local. It is not saying anything. It is active. It is initializing. So states we talked about. See all the options now we are, it is green. Okay. Running configuration, it is synchronized now. Okay. Now I'll keep it refreshing. See, it is showing me passive. HA1 is up, HA2 is up, rest all is matching, it is synchronized. But say, see, here it is still showing me that same option. So need not to worry. Just click on refresh here. Okay. So it will give you more information like peer IP address 10.10.10.2, passive, running configuration, synchronized, match, 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 up, up, up. HA1 backup is down because I have configured wrong IP address in HA1. Okay. So our high availability, it is done. It is in sync. Now guys, one important thing. I have not configured any routing here. Okay. Routing I have not configured here, but it has taken routing automatically. Okay. If I'll show you here. Okay. If I'll show you here, you'll find everything identical. Okay. Now see, I'm doing one crazy thing that should not be done. What I'm doing here is I'm shutting this interface down. Okay. 1/6 as well. And now I will be removing this device from failover. I will disable failover. I go for commit. Here you can see it is passive after commit completion. Passive gone. Okay. Here in dashboard, you'll see down, 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 our intentional part. Now going to devices, sorry, my network, virtual router, I'll click delete. What else I can delete? I'll delete objects. Let me delete few application group, reachability test, to see just whether it is getting replicated or not. Okay. So before deleting group, you need to delete from where you have called it. Okay. Now I'll be able to delete. Okay, wonderful. Commit, commit. Now see guys, I was expecting few questions from you, but as I have not seen any questions relating to this, so let me take initiative and tell you. Um, there is an option named save. You can see here save. So what is the meaning of this save? Save means whatever change you have made, you want to keep that change, but you don't want that change to be replicated in your running configuration, or you don't want to change anything in your uh, policy or something like that, but you want to keep that change, and you are not sure whether this change should be loaded as running configuration on your device or not. Okay, so in that case you do this save option. And second thing we have is we have this lock. Okay, so lock means if I want to take this lock, okay, after taking this lock, okay, no one else from apart this admin, no one else will able to commit. Okay, they can do changes, they can save their configuration, but they cannot commit till the time you have lock. Okay, so another important part. So see guys, here I don't have any application group. Okay, I don't have any policy, as you can see here. Okay, failover I just disabled. Okay, so what I'll do, I'll re-enable it, failover, and go to network, just interfaces. Both interfaces are down, intentionally down. I'll put them in auto. Auto means it will check its neighbor. If its neighbor is up, it will be up. If its neighbor is down, it will be down. Okay, okay, commit, commit. Here you can find nothing here written. What my intention with this activity is, I just want to check whether my rules and policies are getting synchronized or not. Okay, close, initial state, go to dashboard. It is down, down, refresh. HA2 is now up. It is now passive, not synchronized yet. So force synchronization will be done like from here. Yes, I want to do synchronization forcefully. Synchronization in process. Okay. Synchronized, wonderful, completed. Refresh, synchronized. Let me check my policy. It's here. Object, it's here. This is my mode active passive. Okay. So let us test one thing. Let us test failover. Okay. interface. What is my firewall IP address? Is it .10? Interface VLAN .10. Okay, I'm able to ping. Just checking routes. Okay. What is my PC IP address? What is my PC IP address? 0.1. So let me try to ping. Okay. Okay. As you know, one-way traffic is allowed, so my PC is able to ping this router. Now I'll keep it -T. Okay. Now what I'll do, I'll go to device. I'll not go to device. I'll just power off it from here. Power off. And see my traffic. Timeout. Timeout. Okay, I think we are missing something. Let me check the state of this firewall. Okay, network. I think switch configuration is not in place. Do show run interface Ethernet. Here it is, Ethernet 1x1, and here it is 3x2. 1x1 and 3x2. Oh, it will not work. 3x2. It will not work because, see guys, what missing was Ethernet 1x1. That is nothing but this interface where we have two sub interfaces on this Palo Alto. Okay, as you can see from configuration. As you can see in configuration, we had VLAN 20 and VLAN 30 IP addresses. Now this is Ethernet. Now Ethernet 1x1, I have divided into two parts, 20 and 30, right? But I have not put this Ethernet 1x1 of this PA2 into trunk port. because trunk port is required when you relay more than 2 VLAN traffic or 2 VLAN information. So this part was missing. So I'll make this identical. Ethernet 3x2 switch port mode trunk. Sorry. Default interface Ethernet 3x2 switch port trunk encapsulation dot 1q switch port mode trunk switch port trunk allow VLAN 20 and 30. Okay, do show run interface Ethernet 3x2 1x1. Both must be identical. Yes, both are identical. Okay, saving configuration. Now going to dashboard. My other firewall is now again up. So preempt worked. Now it is in passive state. As soon as my other firewall comes up, my preempt will come into picture and it will make this firewall up. So let's log in into this. Okay, now see it is active, synchronized, passive, wonderful. So let me again initiate ping. First packet drop, I think all of us knows. Let me go to this and power off. Now my other firewall comes into picture. Now it is taking traffic. We have 3 packet drop here. Okay. So this concludes our failover testing. So any doubts, any issues, please ask. Vincent?
Sorry, I was on mute.
Your voice is very low.
Hello.
Yeah, now it's perfect.
Yeah, yeah. I was saying I was on mute. Yeah, it's okay. It's okay. It's very good. Well done.
Okay. So now my one of my firewall that is primary, it is down. You can see here, and
Okay.
my secondary it comes into picture, and it is managing all the traffic. If I'll, it is showing passive here. When I'll again sync, it will show me active. It will show me all the details here. Okay. It will not. If I reload it, it will not come up as it is down. So let me power on it again. So this concludes our active passive failover. Okay. Now next task that we create for ourselves is creating active failover. Okay. So give me 5 minutes till the time this firewall comes up. Okay. And let's make few changes. After that, let's meet in 5 minutes.
Okay.
So let's continue again. So here we have this Palo Alto is now up. Okay, so I'm just logging in into it. Okay, so logged in. Now this is again my active now, and the peer one is now passive. You can see it is showing active, but it is not actually, it is passive. Okay, so let's do active failover. Go to devices, go to high availability, setup, just change here active, device ID 0. Okay, device, high availability, settings, active, yes. Okay, so what it is saying layer 2 interface is not supported, HA active mode configuration is invalid. So see, I got one extra tab here, active configuration. So I would require one more link, that is HA3 interface. Okay, so I'll go to settings. Okay, I'll define HA3 interface, but we don't have third interface in between two Palo Altos. Okay, so we will not be able to do it, but let us do the configuration. Like what configuration we can do. Interface, let me define any interface. VR virtual router sync, QoS quality of service sync. Tentative hold downtime, it is saying 60 seconds. Disabled. Okay, session uh, session owner selection. Okay, so first packet, wherever it will go, it will make that session. Okay, it is, if you click on primary device, the session will be owned by your primary device. Okay, but it is not recommended. It is recommended to use first packet. Then we have session setup. We have different options. We have primary device who will set up the session, first packet, IP modulo, or IP hash. Okay, so let me keep default IP module. Okay, so that is it. So we'll be defining virtual address. Okay, so virtual address is nothing but the address of device zero priority. Okay, so that IP address will be used for packet forwarding. I think we all might be knowing floating IP. Okay, that is virtual IP that we assign to any device, and that IP keeps one static IP of the device, one physical IP of the device to communicate. So likewise we have here also, right? So With this, we conclude our failover part. Okay. So this completes our failover. Now, important talks.
But actually,
Yeah, Vincent.
when you are doing active, our traffic is handle.
Can you please put your mic near to your mouth so that I can hear you?
Yeah. Can you hear me now? It's
Yeah,
okay.
now, yeah, now it's it's fine. Yeah.
Yeah, I was saying when we are doing active, our traffic is being handled.
Our traffic is being
Handle.
mm-hmm, handled.
Our traffic is being taken by both device.
Okay. How traffic is being handled, right?
Yeah.
Okay. Give me a minute. Let me share my screen. Now I think you can see my screen.
Yes.
Okay. So in spite of drawing two devices, okay, I have to draw two devices. So we have two links. Make it with more colorful. Okay. So here, this is the topology. This is switch. Okay. Behind somewhere from this switch, I'm getting some traffic. After this, I'm getting some traffic. Okay. So these are our links. These are my links HA1 and HA2. HA1 is dedicatedly used for configuration replication. HA2 is dedicatedly using your session table replication. Okay. Now, as we discussed in HA3 interface, also we have, right? So we have HA3 interface also while we configure HA. Okay. So what is the meaning of this HA3 interface? What is the meaning of it?
This is
So
data.
yeah. So this means whatever traffic it will be coming, whatever traffic it will be coming to this box, okay, then this traffic Either it will be going like this to this box, okay? If this link goes down, if sorry, if this link goes down, okay, so my traffic will be going like this, and we will be moving this way, okay? If this link goes down, traffic coming, going like this, it will move like this. If this link is up, if my this link is up, then in that case, it will be like this. But session will be replicated. Session will be replicated in real time. Why? Because this traffic which is going towards this, it will be coming back. It may be coming back like this. Then it will be entertained like this, right? Then it will go like this. In this term, if we talk in relation to this, check. If we talk in relation to this part, okay, this is nothing but a symmetric path, okay. This is asymmetric path. It will go like this, right? So this HA3 needs to be configured when we configure active. So your packet flow will be like this, okay? But in case, let's talk about another scenario. But let's take in a case, so now in this case, your traffic is going like this, coming back, like this, okay, to this firewall, PA1. And now this interface goes down. Accidentally, this interface goes down. This is not working, okay. So now your traffic will be going in this manner, right? So this is the utility of HA3 interface.
Okay.
So did I reply your question, Vincent?
Yes, yes, yes. I didn't know this option in Palo Alto.
Yeah. So you can understand it in other way that whatever feature, whatever interface you have in your Palo Alto, okay, it will be dedicated for a particular service. For example, HA1 will only and only be used for configuration replication. HA2 will only be used for session replication. HA3 will be used for traffic flow.
Mhm.
Okay,
Yes.
so I think we are very much clear.
Yes.
Wonderful. So this is how it works, but we don't have HA3, so we won't be doing practical for that. But yeah, now we are very much good
But
with
this
these. Yes, please.
HA3 limitation is due to license or what? Or
Uh,
network architecture?
High availability?
Yeah, the HA3.
No, no, no. License is not required as if now. But yes, if you have any deployment, see, now we are doing lab environment, test environment, right? So we don't have any license. But when we talk in industry, there are few prerequisites, okay,
Okay.
which are need to be met in order to do HA, okay. So you first need to meet all the HA prerequisites, after which you will be doing HA, high availability configuration.
Yes.
If one of your device has URL filtering license, other device does not have URL filtering license. I'm just taking example, okay? So in that case, what will HA do? HA will not be able to do URL filtering, right?
Yes.
Because one device has license, other one does not have. Likewise, one device is having wildfire license, other device does not have wildfire license, okay? So in that case also, it will not be in HA,
Okay.
okay?
Yes. Thanks.
So I think we are good with the HA now, okay?
Very good.
So let's start with our next lecture. That will be our VPN, virtual private network.
Ah,
Okay. So what is VPN?
it's a tunnel between two devices.
Wonderful. It is tunnel. It is secure path over insecure path.
It's a
So
secure path.
yeah, it is secure path over unsecure path, or you can say it is secure path over internet.
Yep.
So let's discuss about this VPN, and hopefully we'll be able to finish this theory part. We'll be taking practical path or practical part in our next lecture. Okay, VPN.
Okay. Yep.
So VPN on Palo Alto, virtual private network. Create tunnels that allow user or system to connect securely over a public network, as if they were connected over a local area network.
Yes.
So, as you said, Minson, it is secure path over public network. Next is type of VPN support. So different types of VPNs that are supported in Palo Alto: site-to-site VPN, A simple VPN that connects a central site and a remote site, or a hub and spoke VPN. The firewall uses the IP security IPsec set of protocols to set up a secure tunnel for traffic between the two sites. Okay, so
Yes.
remote user to site, very much clear. A solution that uses the global protect agent to allow a remote user to establish a secure connection to the firewall. This solution uses SSL and IPsec to establish a secure connection between the user and the site. Then we have large scale VPN. The Palo Alto Global Protect large scale VPN provide a simplified mechanism to roll out a scalable hub and spoke VPN with up to 1024 satellite offices. The solution requires Palo Alto network to be deployed at the hub and at every spoke. It uses certificate for device authentication, SSL for securing communication between all components, and IPsec to secure data. Okay, excuse me. So remote access, or you can say remote user to site VPN. It uses license because it uses global protect. And then we have large scale VPN. In Cisco we have hub spoke topology. Same we have in Palo Alto as well. But prerequisite is at every spoke location we must be having Palo Alto,
Yep.
and at hub location also we must have Palo Alto.
Okay, so in a two type of VPN, we use Global Protect
Mm-hmm.
for remote user to site VPN and large scale VPN.
Uh, uh, it's a bit same, but a bit wrong. Okay, let me give you a brief of this. Very first part is clear, site to site VPN. It is nothing but two physical locations, X number of users behind both the locations. They will be using
Yes.
this connection. Next, we have remote user to site. Here we talk about only one user is accessing our particular location. For example, you are doing work from home.
Yeah.
Okay, that is a type of connection we call remote user to site, because you are connecting to your organization to do work from home, right?
Yes.
Next, we have large scale VPN. We all know there is a topology, or there are scenarios, multiple scenarios where we have one headquarter and we have different branches working under that particular headquarter. So
Yes.
what type of VPN that you suggest? You suggest hub and spoke topology, or hub and spoke VPN connection, right?
Yes.
So
Yep.
in Cisco, we have DMVPN, that is dynamic multi-point VPN, right?
Yes.
So likewise, that DMVPN in Palo Alto, it is nothing but large scale
Large.
VPN.
Okay. We have one hub and many spoke talking to
Correct.
the yeah the hub. Yeah.
But in Palo Alto, you have limitations. How many sites you can integrate to one hub? It is 1024.
Okay.
Okay,
I see too much.
it is too much, I think. Okay, so another big issue for an organization to use this is you should have same Palo Alto or same vendor Palo Alto device at every location. That is at all the spoke locations.
Yes. Limitation.
Where is the challenge here? Suppose I am working for an organization, suppose ABCD, and now that organization is doing very well in market. Now it is heading towards being a giant in its department. Now we have another organization named OA. O as an opera, A
Yeah.
as an alpha. So we have another organization named OA that is also doing good, but not as good as it should be. So my ABCD organization decides to purchase OA and make a collaboration,
Yeah.
purchase all, like say, all the infrastructure of that organization and all the working members. Everything it will purchase. Now, what is the challenge? My OA organization also have few branches under it. My OA organization also have separate departments, separate infrastructure, but it does not have any Palo Alto device.
Uh,
So if I want to integrate that OA to my ABCD and my ABCD is using Palo Alto large scale VPN, so my ABCD has to purchase Palo Alto and deploy it to OA in OA infrastructure to connect over VPN.
okay.
So this is our challenge.
Yes.
So I think I'm very much clear with my point.
Um, if you can you say it again because I'm a little bit confused.
Wonderful. I need that confusion. Give me a moment. I need this confusion. This confusion will give you clarity.
Thank you.
So this is my head office. This is my branch office. This is my headquarters. This is my PA 1 and 2. Here I do not have, here I have ASA, for example.
Okay.
Okay. So I'll not be able to use this
Live stream.
VPN. Yes, absolutely right.
Okay.
I'll not be use large scale VPN because in order to use this large scale VPN, I should have one Palo Alto here.
Okay.
So what I need to do here is I need to install this is my ASA, and after this ASA I'll be installing my PA, whatever box. Okay.
Um, yeah.
Now after installing that, I will be able to connect to my headquarters with
Live
LSVPN.
scale. Okay.
So this part, this part increased my cost.
Yes.
because I have to uh, align one resource to manage this. I have to purchase license, separate license for this, and I have to pay more electricity bill for this Palo Alto. Okay, so these are this is the sort of challenge that we face. Okay,
Mm-hmm.
so now let's move to next slide, site-to-site VPN. Let's discuss this. It is a VPN connection that allows you to connect two or more LANs over internet link. Very much clear.
Yes.
The IPsec set of protocol is used to set up a secure tunnel for the VPN traffic, and the information in TCP IP packet is secured and encrypted if the tunnel type of ESP. Okay,
Yep.
encapsulated. Then we have component needed for VPN connection. Okay, let me see whether my Palo Altos are on. No. Okay, so Palo Altos are not on. So next lecture only we'll be discussing it. So component needed for VPN connection, it will be IKE gateway. Okay, IKE is infrastructure key exchange. Then we have tunnel interface. Then we have tunnel monitoring. Then we have internet key exchange, IKE version 1 for VPN, or IKE v2. Okay, there is difference between IKE gateway and IKE v1 and v2. Okay,
Mm-hmm.
so when we will be configuring, we'll be discussing it. But with
Okay.
the name, it is very much clear.
Yes.
IKE gateway is the next hop where it will land, and IKE is the key that that we define, like which type of IKE we'll be using, version 1 or version 2 for that particular VPN. So now we have IKE gateway, Palo Alto firewall, or a firewall that initiate and terminate VPN connection across the two networks are called IKE gateway. Okay,
Yep.
same thing. It is PA firewall, or a firewall that initiate and terminate VPN connection across the network. Then we have to set up the VPN tunnel and send traffic between the IKE gateways. Each peer must have an IP address, static or dynamic, or FQDN, that is fully qualified domain name.
Yes.
Okay. Then we have the peers must also negotiate the mode, that is main or aggressive, for setting up the VPN tunnel and security association lifetime in IKE phase 1. I think we are very much clear with IKE, or with site-to-site VPNs,
Yes.
that we have two phases. Well, first phase is IKE, or you can say crypto ISACamp, and the second phase is IPsec, where we have our traffic encapsulated, okay,
Yes.
encryption of our traffic. So the same thing in layman language. Next, we have two modes, that is main mode and aggressive mode. Main mode protect the identity of the peer and is more secure more secure because more packets are exchanged when setting up the tunnel. So I think if we know the VPN technology, we know
Yeah.
main and aggressive mode. Okay.
Yes.
So next is aggressive mode. Aggressive mode uses fewer packets to set up the VPN tunnel and is hence faster but a less secure option for setting up the VPN. Okay, very much lemon. Next we have tunnel interface. A tunnel interface is a logical, that is virtual interface that is used to deliver traffic between two endpoints. Okay, so when we were configuring our interface after going into network, we were having option Ethernet, VLAN, tunnel, and loopback. We configured Ethernet and VLAN. Okay, so In Ethernet, we were not having option of VPN type. We were not having option of VPN type, right? We were having option of tap, virtual wire, excuse me, tap, virtual wire, high availability, layer 3, and layer 2. These were the options that we were having while configuring or while setting up interface of uh, Ethernet interface in Palo Alto.
Okay.
So we were not having any VPN interface. So in order to make an interface to communicate for VPN, we have to create tunnel interface. We have
Yes.
to assign IP address to that particular tunnel interface.
Mhm.
In Cisco, what we do, we create some crypto map. And in crypto map, we call that crypto map to that particular physical or that particular loopback interface that we are using to communicate.
Yes.
Likewise, we'll do in this as well. Okay.
Yeah.
So what is it is saying? It is saying to set up a VPN tunnel, the layer 3 interface at each end must have a logical tunnel interface for the firewall to connect to and establish a VPN tunnel. The layer 3
Yes.
interface that the tunnel interface is attached to belongs to an external zone, for example, the untrusted zone. You know, untrusted zone, which is towards your internet facing.
Yes.
To route traffic between the sites, a tunnel interface does not require an IP address. An IP address is only required if you want to enable tunnel monitoring or if you are using a dynamic routing protocol to route traffic across the tunnel. Again, very much clear.
Uh, Not clear because it's a layer 3 interface,
Yes,
and here we say that we don't require an IP address.
right.
I
See,
don't get this.
yes, absolutely right. So in third point, you'll see the layer 3 interface that the tunnel interface is attached. Tunnel interface is always attached to belongs to an external zone interface.
Okay.
Getting? Now see,
Yeah.
first four letters in point 3, first
Yes.
four letters, that is layer 3 interface. We
Yes.
are talking about Ethernet, where we
Yes.
have HA, TAP, layer 3, layer 2 interfaces. We are talking
Yes.
about that interface. And this is another tab like Ethernet VLAN. Likewise, we have tab tunnel. We are talking about that tunnel. Now we are binding this tunnel interface to
Ah,
layer
okay.
3 interface.
Okay. 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 Yes. Yes.
Okay.
Yes.
So this tunnel interface, it will not be communicating outside. It will not be communicating to other side. It will be using some source interface. So that source interface must be attached to your untrusted zone, or you can say your internet facing interface.
Yes.
Okay.
Yeah.
The last point, it is again clear after getting clarity on point 3.
Yeah. It's getting clear.
Wonderful. So now we have tunnel monitoring. For a VPN tunnel, you can check connectivity to a destination IP address across a tunnel. Okay.
Yeah.
Then when you establish your tunnel interface, when your VPN is up, how your device will be knowing your tunnel is up? By checking your tunnel, or you
Yes.
say your peer IP address. Okay.
Yeah.
So network monitoring profile on firewall allows you to verify connectivity using ICMP to a destination IP address or a next hop at a specified polling interval, and to specify an action on failover to access the monitored IP address. Same thing, like it will check its neighbor, its peer IP address in this monitoring. How it will check? It will use ICMP packet to check. After a certain time interval, it will send ICMP echo request. It will get ICMP echo reply. It will verify with reply. It is getting, if it is getting reply, tunnel is up. Okay.
Yes.
So next is Internet Key Exchange, IKE for VPN. IKE process allows the VPN peers at both ends of the tunnel to encrypt and decrypt packets using mutually agreed upon keys or certificate and method of encryption. Okay, so it is
Yes.
your certificate based, or it will be your defined encryption type. So IKE process occurs in two phases, IKE phase 1 and IKE phase 2.
Two.
So let's talk about IKE phase 1. IKE phase 1 for security gateway. So this will be the process. So what it is saying peer authenticate using certificate or a pre-shared key. From a pool of random bits, each side produces a Diffie-Hellman private key. Each peer derives a DH Diffie-Hellman public key from its private key. Public keys are exchanged. Each side produces a shared secret key. I think diagram is very much layman. You can
Yeah.
understand it. No need of reading all the bullet points. Okay,
Yes. Yes.
so let's skip it. So this is your phase 2. Okay, phase 2 symmetrical keys, symmetrical keys. Phase 1 DH keys, phase 1 DH keys, IPsec key, IPsec key. Okay,
Yes.
so this is the working of your VPN, any VPN. Talk about any VPN, site to site, remote access, whatsoever it is. Okay.
Yes.
Next is IPsec. Now see in the last point you will see IPsec key, IPsec key. Okay. Now this is your IPsec. Your data is encrypted. Encryption, decryption, encryption, decryption with the keys. IK negotiation build the tunnel. IPsec key used to create encrypted IP packet for transporting data. Data payload encrypted. Data integrity ensured with one-way hash function MD5 for SHA. Fast bulk data transfer. Okay, very much lemon.
Yeah.
Standards used for encryption in IK phase 1 or IK version 1. DH. So DH means Diffie-Hellman, group 1 768, group 2 1024 51536, group 14 2048. Okay, so it is very much known. Okay, so when we will be configuring it, we'll be discussing it in more details. Okay, then we have authentication algorithm. It is SHA-1 256 384 512 MD5. Now remember one thing: don't configure your authentication algorithm based on the options you have. Always configure authentication algorithms based on the algorithm that your peer can support.
Yes. True.
Okay.
Yeah.
Next, encryption algorithm. It is 3 DES, AES 128, AES 192, 256, or DES. DES 3 DES and AES. DES 3 DES. These are very much vulnerable and getting obsolete nowadays. Okay. AES 128, a bit secure. AES 192 is recommended. AES 256 is
Yes.
desirable.
Okay.
Okay.
Yes.
Next, IPsec uses the following protocol to enable secure communication. Okay, it is encapsulation security payload ESP, AH authentication header. The working is just the same as it is working in any other device. Okay, so you may go through these slides and ask me any doubts if you have.
Yes.
So I think we are good with the slides. Okay, so we are good for today's lecture. Okay,
Okay. Yeah.
so we'll be configuring this VPN
VPN for next.
in our next session, site to site. Okay,
Okay. Yeah.
and we will see whether we will be able to configure it or not. Okay,
Why?
because we have two Palo Altos. Okay,
Ah,
so
yeah.
we have to remove them from failover and all those stuff. So if we do any VPN stuff, we won't be able to do failover.
But we can make a VPN between
Yes,
Palo
yes.
Alto and the